Ever pondered why it's impossible to create something out of nothing? Let's take a moment to dive deep into this profound inquiry which has bemused the greatest of minds for centuries. Indeed, it is a question that has kept philosophers, scientists, and thinkers awake at night, pondering the mysteries of the universe. Fascinating question has roots that delve deep into the annals of scientific history, a question that has spawned countless debates and discussions among the intellectual elite. It's a puzzle, a conundrum, a riddle of cosmic proportions that has sparked the curiosity of mankind and propelled our quest for knowledge. So let us prepare to journey the complexities and subtleties of this fascinating question. Get ready to set foot into the realm of science, where this age-old mystery is housed. Here, amidst the endless sea of knowledge, we find our answer elegantly wrapped within the principles of physics. Our answer is encapsulated in the first law of thermodynamics, a fundamental principle that serves as a cornerstone in the edifice of modern physics. This law, also known as the law of energy conservation, is a decree that governs the dance of energy in the universe. It is a statement of an inescapable reality that energy, in its essence, is eternal and indestructible. This law solemnly proclaims that energy cannot be created or destroyed. It can only be transferred or transformed. It's a fundamental truth about the universe, a rule that stands unchallenged and unbroken. This law, with its profound implications, thus elegantly answers our initial query. So now you see, the reason we can't create something out of nothing is simply because energy is preserved, energy is eternal, and energy is all there is. Energy cannot be created or destroyed. It can only be transferred or transformed. Imagine a cup of hot coffee sitting on a table. This picture seems simple and quite ordinary, but it holds within it a complex scientific concept that is fundamental to our understanding of the universe. As you observe the coffee, over time, you'll notice a change. The coffee cools down. It loses its initial heat, its initial energy. But have you ever stopped and yourself, where does the heat go? This question brings us to a fundamental law of the universe. It's a principle that governs everything around us, everything that we see, feel, and experience. It's a law that states that energy cannot be created or destroyed. It can only change forms. So where does the heat go? It doesn't just evaporate, it doesn't just disappear into thin air, contrary to what we might casually think. Instead, the heat from the coffee transfers itself into the surrounding environment. This heat energy radiates outwards, dispersed in the air around the cup. It warms up the air, changing its physical state from being cooler to slightly warmer. This is a clear example of energy changing forms, from the thermal energy in the coffee to the warmer air. So, you may be asking yourself a rather puzzling question. What does this seemingly mundane cup of coffee have to do with the grand idea of creation, of making something out of nothing? The answer is everything. Here's the interesting part, the fun part. Everything in the universe, from the smallest particle to the largest galaxy, is composed of energy. Everything that exists, that we can see or feel, is energy in one form or another. This energy, in its countless forms, is the fundamental building block of all matter. From the stars in the sky to the coffee in your cup, everything is a manifestation of energy. Thus, to create something out of nothing, in essence, would mean to create energy out of nothing. This is a clear and undeniable violation of the first law of thermodynamics, a law that governs the very fabric of our universe. It's akin to trying to bake a cake without any ingredients. It's an attempt to do the impossible. It cannot be done. It simply can't be done. This concept also applies to the universe as a whole. The vast cosmos that we live in, infinitely expanding, full of matter, energy, and potential, isn't as arbitrary as we might think. It's governed by processes, rules, and laws that we are only just beginning to understand. One such understanding comes from the Big Bang Theory, a cornerstone of modern cosmology. The Big Bang Theory, as its name might suggest, tends to conjure images of a colossal explosion. However, it's imperative to understand that it's not a depiction of an explosive outburst out of nothingness. This theory, the leading explanation for the origin of the universe, does not suggest creation ex nihilo, out of nothing, a term often misunderstood or misrepresented. Rather, the Big Bang Theory paints a picture of an initial singularity, a state of infinite density and near infinite temperature. This singularity, occupying a point in space with no dimension, was a hot, dense point from which our universe evolved. It's here, in this high density and high temperature state, that our story begins. In this state, the universe was no bigger than an atom, yet it contained all the energy and matter that we see today. Packed into this tiny space, this energy was not simply created. No, the laws of physics, as we understand them, prohibit the creation of matter and energy out of nowhere. The concept of conservation holds true even at the birth of the universe. So, what happened then? The universe underwent rapid inflation, expanding exponentially in every direction. This expansion transformed the energy within that original singularity into the matter and energy forms we recognize today. Once again, we see that energy was not created, it was transformed. In conclusion, the impossibility of creating something out of nothing is not merely a philosophical or metaphysical concept. It's a much deeper, more intricate understanding that engulfs our conception of the world around us. This concept inherently is a basic rule of physics, a science that has repeatedly proven to be the backbone of our understanding of the universe itself. These concepts, these laws, are not simply theories or conjectures, but they are interwoven into the very fabric of the cosmos, the universe that we are a part of. Physics, as a discipline, offers profound insights into the natural world and the cosmos. It has revolutionized our understanding of reality, from the microscopic world of atoms to the grand scale of galaxies and the universe. Physics, essence, allows us to comprehend nature's most profound laws, and among them is the law that states the impossibility of creating something from nothing. This principle is formally known as the first law of thermodynamics. This law, often referred to as the law of energy conservation, provides a rigorous framework that explains a fundamental aspect of our physical reality. It postulates that energy can neither be created nor destroyed. Instead, energy can only be transferred or transformed from one form to another. This seemingly simple yet profound concept is a cornerstone of physics, governing the workings of our universe. The first law of thermodynamics, in essence, is a custodian of energy. It safeguards the constancy of energy, ensuring that the total energy in an isolated system remains constant, even though it might change forms. It dictates the flow of energy, ensuring that nothing can be created from nothingness. It is this law that stands as a sentinel, blocking our attempts to create something from nothing, asserting the impossibility of this notion. So let's consider a simple, everyday example to illustrate this law. Imagine you are sipping on a cup of coffee. As the coffee cools down, it might seem as though the energy is disappearing. However, in truth, the energy is not vanishing. It's merely being transformed and transferred, following the first law of thermodynamics. The heat from the coffee is transferred to the surrounding air, warming it slightly. This is a small-scale illustration of the grand cosmic dance of energy transfer and transformation, a dance that our universe has been performing since its very inception. So the next time you sip on a cup of coffee, remember, even as it cools down, it's still playing its part in the grand cosmic dance of energy transfer and transformation, a dance that has been going on since the dawn of time and will continue until the end of the universe.